Good morning. Well, that's great. I love this crowd. Well, welcome to reInvent in Las Vegas. I'm excited to be here with you today. This is my 13th reInvent. I attended first 6, like many of you in this room, as a customer of AWS. And this is my 7th one as a builder here at AWS. Now, in my role at AWS, I wear dual hat. I get to lead and build and solve business problems using technology and AI. And I also get to work with C-suite and executives of some of our largest customers like yourselves. How many of you in the room are first time at reInvent? Show of hand. Well, wow, many. Welcome. Any veterans here, 5+ years? Excellent. Well, I hope you have a fantastic week because it's an amazing time to be a senior leader in the organization. What a privilege that we all have to become the agent of change and lead our organizations beyond just automation to high agency. So in this session, over the next 40 minutes or so, I'm going to talk about what do leaders need to do to lead in this new era of high agency? What are the mental model shifts that we require as leadership team? How do we re-envision our business processes? And then go slightly deeper into some of the technical and architectural capability that help bring this vision to life. So let's dive in. Now, I'm sure many of you have seen a lot of things being labeled as agents. But when you peel back that wrapper, underneath that, you find many of these things. You have just good old scripted automation that takes repetitive, predictable tasks and in a fixed set of workflows, codes it. As you move up that autonomy chain, you have generative AI assistants and the chatbots that provide useful information, has access to data, can respond to queries, can actually summarize the document and information, and has an ability to respond, but very limited ability to act. As you move up that autonomy chain, we start to see higher order business tasks and the goal that these agents can do. The goal and task-based agents are optimized for completing a specific task by working with humans. This is where we start to see a lot higher value. And then at pretty high up is the highest level of autonomy of agentic system, where multiple agents work together, take a much higher order, complex, and sometimes ambiguous task, and are able to break that down into steps and pursue that. So this is a good mental model to think about when your teams come and talk to you about automation or AI agents. Now, this is not to say that one is better than the other. As senior leaders, it is important that we understand what tool to apply to solve which problem. So the question that I really find useful when I'm talking to my team is to what are the behaviors or attributes that make something an agentic system? So let's talk about what are some of those behaviors. Agentic systems are goal-driven. As I talked about, they take a higher order goal or an intent and have an ability to break that into multiple chunks of tasks to go and complete. They are resourceful. They have an ability to access the tools, the data, the context, the hierarchy, and the roles inside of your organization to take those actions. They remember. They have a memory so that you don't start again when you have a new transaction. They remember that there was an issue with the billing last time I tried to do something. They learn and adapt. They get better with the feedback. And they use escalation, not just as a mechanism when something is wrong, but as an inbuilt trust mechanism to involve human in the loop. So it's good to keep this framing in mind when you think about agentic system. Now, you might ask, well, we've been on this journey for a couple of years now. So why now? What has changed? And there are two fundamental shifts that are happening very, very rapidly that we as senior leaders need to pay attention to. The first thing that is happening is that the unit of task or the length of task that AI can do is doubling roughly every 7 months or so. So you now can take a lot more complex tasks and give agents to go and accomplish those tasks. Now, as senior leaders, we know that just having a technology or tool that is very intelligent and highly capable but is extremely expensive and unaffordable, is not very useful, is it? So what is also happening on the other end is that the unit price or the cost to access this intelligence is continuously dropping as well. MMLU is a standard benchmark, massive multi-language task understanding, and that is used to benchmark language models. And just to give you the context, an MMLU of 43 is similar to a struggling high schooler. They mostly are guessing answers, but they are very confident. I have one at home, so I know how that feels like. I'm sure many of you do too. But MMLU of 83 is like a PhD level expert. They understand the nuance. They are able to deal with ambiguity. And so we can see that MMLU and the unit price to access both of this is dropping. So we are in this sweet spot where the capability are increasing and the unit price and the cost is dropping. And this is why we are starting to see real-world applications of agents. Druva is a data security company. I'm sure many of you in this room use them. Now, when you're dealing with a cybersecurity incident, a ransomware attack, you don't have time to go through like thousands of pieces of logs and information manually to sift through that when you're in the middle of the crisis. And so Druva worked with AWS to build Drew AI. These are agents that don't just respond, but they take action. They look at proactively the logs and autonomously detect the system issues. And then they take corrective action. They move the data around. They update the policies. They move the data to a storage that is a lot more cost-effective based on the data retention and the policies that you set, driving a lot higher value. But to take advantage of this requires a change in how we lead. If you think about historically, leadership has been mainly about optimizing for determinism. We are all rewarded for lowering and reducing deviation, having repeatable, predictable processes that do the same thing over and over again by reducing the error rate. And now this works today. But the non-determinism, the ability to improvise, the ability to adapt, the ability to take different action based on the context and changing requirement with agent is a feature, not a bug. Now, I'm sure this might make some of us nervous, especially from regulated industries. So this is not about just stepping into the Wild West. This is about us as leaders being aware that the non-determinism is what gives agents the power, and how do we safely harness this by setting up the right guardrails. And the mental model that I find useful is to think about how we work with some of our high agency teammates. You don't call your high agency teammate every Monday and say, hey, I'm going to sit down with you to give you specific tasks that you're going to execute every single day, and then you're going to come and at the end of the day report to me what you did. Right? We actually give them a strategic higher order intent. We give them the boundaries within which they can operate. We empower them with the right resources and access that they need to get the job done. And then we trust them to escalate to us and involve us as needed. And so to lead in this high agency requires a shift in the leadership model, because we are no longer managing automation. We are managing thousands of agents at scale. And that intelligent autonomy and managing that at scale requires shift into 4 key areas of leadership. Now, please keep in mind that the mental model that I'm going to share are just mental models. They are not recipes or strict operating model, so take them with that lens. And 4 areas that I'm going to cover, starting with governance. Now, traditionally, whether it is in software or in compliance, we have gate-based governance. System moves, comes to a complete stop, waits for someone to verify a series of things via a checklist that has been defined and maybe audited a couple of times a year. They approve it, then the system moves again, stops again at the next toll gate. Now, this works today, but when you have hundreds and thousands of agents, you can't put these toll booths in front of them consistently. That will just slow it down. Instead, the mental model that is useful is to think about providing that strategic intent and then having a policy engine that can govern this at scale. And as I was thinking about, well, what governs like this? The thing that came to my mind is that if you look at how board of directors actually work with the CEO, once again, they don't go to CEO and say, I'm going to tell you exactly how to run your company every single day. Board and CEO typically align on a strategic direction and the vision. Periodically, they go and audit and calibrate, but there is also specific guardrails around what requires board approval. And the management team knows when to engage the board. So it's a useful mental model to think about governance this way. The second shift is in risk. Now today, our risk management controls are pretty much like a factory floor. On a factory floor, you have fixed threshold. Right? Even today, in many of our organizations, we have fixed threshold regardless of the exposure of the risk. So if a purchase order is more than $2 million, it requires approval of a vice president. If it is beyond $10 million, it must go to the CFO. Now, these controls for risk break down when you're dealing with autonomy at scale. The mental model that I find useful is to think about managing the risk like a trading floor. And on a trading floor, the risk is actually managed a lot more aggressively. But it is managed through real-time visibility and control. Traders have a portfolio that they can play the trades in. Not every move is managed, but if the portfolio or a particular transaction violates the policy, then there are circuit breakers that stops the trading. Let's say the portfolio drops by 20%, the circuit breaker kicks in and stops the trading. And so we need to think about agents this way, where agents have to earn their liquidity by operating within the risk controls and the boundaries that we design, and have it with real-time visibility and automation. And it's also not about managing every single agentic transaction, but also monitoring the systematic drift in a multi-agent system. When that happens, you want the circuit breakers to kick in. One of the most fundamental change, though, is going to be in the organization structure. And again, as leaders, we all know this. Every single time there has been a major technological change that has required us to reimagine and rethink how we organize. Before cloud, we had application and development teams, and then infrastructure and technology operation team. When cloud came, these boundaries got blurred. You started to get full-stack engineering teams that can operate at all layers of the stack. In fact, with agents, we are seeing this inside of our own teams, where boundaries beyond just engineering, including the business process roles, product management, engineering, TPMs, are all getting blurred because you have an ability to execute and work with agents throughout the entire value chain. Historically, our org structures are vertically optimized. Now, this structure provides us stability, but it is not designed to move fast. If a customer has an issue, that gets handed off sequentially between the department, from customer support to supply chain to distribution to return and refund, and it slows it down. But the mental model to use in terms of how you organize for agents is like an immune system. How does our body's immune system work? If there is a threat or if there is a problem, our white blood cells don't wait for a memo from the brain. Right? They don't call a meeting with the lungs. They actually swarm that problem and then figure out how to solve that. So the cross-functional teams that are organized around a business workflow, regardless of the current departmental structure, is how you really get outcome from agents. The other thing that happens in this kind of org structure is that system learns constantly. So it's sort of like creating antibodies, right? So when you have this responsive swarm, it gets better with period of time. The last piece, and so before I go there, really what we need to think about is that agents should not be limited by your org chart. They should be limited by the objective that they are pursuing. That brings us to the last part of this leadership mental model, and that is around culture. Historically, we have all optimized the culture for precision. It's sort of like, well, you gotta almost hit a bullseye every single time. That's what we reward, a perfect execution. But what happens in a research lab-like culture? That culture is open to new discovery. Sometimes good, sometimes bad, but if those mistakes happen, they are used as a learning mechanism. They are documented, they are shared widely, and the new discovery and adaptation is once again a feature, not a bug in this kind of a culture. And so that's the shift that we need, because what we are trying to scale is not obedience. We are actually trying to scale the intelligence throughout our organization. And so the 4 key leadership mental model shifts that I talked about: governance, like board of directors, that provides strategic direction, the continuous calibration and the guardrail; risk management, like a trading floor, where you have real-time visibility and circuit breakers, and then agents earn their liquidity and authority to operate by consistently showing us that they're operating within those risk controls. The organization structure, that is like an immune system, that is a lot more fluid and responsive. And then finally, the culture, that is like a research lab culture that is open to new discoveries. If you want to read more, you can scan that QR code and dive deeper into some of these mental models. Now, I want to talk about the business process. And I'm going to pick a business process that I'm pretty sure most of us in this room are familiar with, which is accounts payable. Now, traditionally, the goal of an accounts payable business process has been to pay invoices on time and accurately. And I want all of us to time travel to pre-ERP days, right? So just stay with me here. In the pre-ERP days, what happened was that an account payable system had a fixed goal to pay every invoice on time and accurately, but the workflows were vertical. So procurement will process the PO, receiving will confirm the receipt of the goods, treasury will make the payment, and AP will post the invoice, and so on. The SOPs were all vertically inside of each of the department and the function, and then there was sequential handoff that happened. Now, in this kind of a system, if there was any error or an issue, it will manually get kicked back into the previous process. Somebody will have to call that department to fix that issue. How many of you in the room have been part of an ERP implementation or run an ERP? Okay, several of you. Now, what happened during ERP is that we could not look at these vertical processes. We had to re-engineer an AP process horizontally. We had to connect the dots between procurement, receiving, treasury, AP, and so on. That forced us to talk across department and function to relay out our business process. But there was still limitation because the goal was still fixed, which was to pay the invoices on time and accurately. And if there was an issue, anytime during the process, it will get kicked back, and then manually you will have to handle the exception. Now, what if in an agentic system that I described earlier, we take a lot higher magnitude goal? What if the goal of AP is not just to pay invoice on time, but to optimize our cash flow? And the system has the freedom to operate fluidly within the boundaries that we set. So a particular invoice will go through all of the steps, but then a second invoice comes in, and the agents will know that this invoice is in euro. And I have a 60-day payment term on this particular invoice. That means I'm going to call a Forex trading agent and say, can I invest this for 59 days and actually improve my cash flow? Or a third invoice comes in, and it recognizes that last 4 times I approved this particular vendor payment, it had to go into dispute because we did not like the quality of the deliverable that the vendor had. And so this time, I'm going to proactively bring human in the loop and say, even though approval processes have confirmed, I'm going to involve the human and say, hey, last 4 times we didn't like what happened here. Do you still want me to pay? And so that's a lot higher order task, but also a lot more fluid workflows that are happening here. Today, though, as I was talking about, we are already seeing goal-based agents being in play. This is where you have a planning agent or a planner that takes this higher order task, breaks it into manageable chunk, and then you have orchestrator that works across individual agents inside of each of the function like procurement, receiving, AP, treasury, and goods to get to the payment and reduce the cycle time. In fact, we are seeing this in Amazon as well. I'll give you an example of an orchestrator within Amazon. In our warehouses, we have over 1 million robots that actually help us safely and quickly move the packages around. And we have this orchestrator called Deep Fleet. Sort of think about this as a brain of this robotic fleet that manages these 1 million robots distributed all over the world across our warehouses. And by constantly optimizing that, we are able to reduce the travel time by 10%. Now, 10% may not sound a lot, but at our scale, with million robots and multiple hundreds of warehouses and distribution center, that means that we are able to get the packages faster to you. And so that's an example of an orchestrator operating at scale, optimizing the business outcome. Now, earlier I talked about the behaviors of an agentic system. Let's double click. We talked about the behaviors, we talked about the leadership mental model, as well as the business process changes. Let's double click and say, what are the technical capabilities that bring these behaviors to life? And there are 3 things that agents need. And again, if you want to geek out a little bit more in architectural implication, you can scan this QR code and read an article that dives a lot deeper into the architectural implication in your environment. But really, agents need 3 things. They need intelligence, they need context, and they need trust. And if we were to think of agent as sort of human body, here is how that looks like. The intelligence is sort of like the brain of the agentic system. And your models, including your thinking model for chain of thought reasoning, reflection, they provide the brain an ability to take the intent and break it into task. But just having a brain is sort of like having a brain in a jar, right? It cannot take any action. So you then have the access, the context, which provides agent an ability to access the right data. It provides an ability to actually take action. It provides an ability to access the tools to go and make things happen. And that's sort of like having the hands to go and do the work. But without trust, none of this matters. And so the final layer of this is the trust. It is sort of like having an ID badge. What is the agent's identity? Who are they operating on behalf? What are their authorizations to execute and do this task? And then what are the guardrails that they are going to operate within to make sure that they are doing this safely? And so let's double click on each one of them and say, what are some of the implications in terms of technical choices that we have to make? So the first thing is that agents need intelligence. Now, in an ideal world, we would want the most intelligent agent at the lowest possible price at the fastest possible speed. That we want to optimize on all 3 of them. But in real life, based on your use case, based on the problem that you're trying to solve, you might not need all 3 of these in equal measure. In fact, there is a trade-off. So if you're working with an agent that is legal agent, you might say, hey, you know what? I cannot compromise on accuracy and intelligence here. But I'm okay if it takes half a day or a few more hours or even a day to give me the response. So I'm going to optimize for intelligence, but I'm okay to trade off on speed of response. On the other hand, if you're dealing with a customer service agent, you want fast, quick responses because your customers are not going to wait for 10 minutes for agent to come back with a 100% accurate answer. And so this is where you optimize for speed, but then you can trade off on intelligence or the cost. And this is why when we are thinking of enabling the intelligence in the agentic system, the choice of models, having access to different types of model is very important. because every model has a different strength. Some models are good with reasoning, others are very good with quick responses, some do text-based tasks really well, others do images and mathematical tasks really well. And so this is why our approach with Amazon Bedrock has been to make the broadest and the widest set of models available, including open source model, Amazon's own model with Noah, as well as a lot of third-party models. And we see this application inside of Amazon businesses across our company. Take example of pharmacy. Now at Amazon Pharmacy, our goal is to reduce the time it takes to fill your prescription and do that accurately. And sometimes the prescriptions are handwritten notes, and this is where we use models and intelligence to reduce the time by 90% while reducing the error rate by 50%. On the other hand, on Amazon ad side, we want to provide the ability for brands who want to advertise to take an image of their product and actually touch it up and make it better and make it a lot more compelling when they list it. And this is where we optimize for ability to generate compelling images. On the Prime Video side, any football fans in the house? All right, some of you. If you're like me, you always join the game a little bit late, and then you're like, what did I miss? And so you have the feature of rapid recap, which is where model is going and saying, here are the key things or key plays that happen, and let me catch you up as you come in. Or next-gen stats, which actually provides a lot more probability and information to the viewer, bringing them closer to the action. All of these use cases require different behaviors and different models. Take example of our customer, Syngenta. Now, farming, if you think about it, is one of the most complex multivariate problems. Right? A farmer has to take into account so many different things. What is the weather condition? What seed to plant? When do I plant it? What pesticide to use? How much should I spray? Do I fertilize or not? When do I fertilize it? Now, these are just the factors that are in their control. But they are all dependent on so many other external factors. The soil condition, the moisture, the weather pattern, the pest activity in that particular area. And this is why Syngenta worked with AWS to develop CropWise AI, a series of agents that take information from multiple different data sources, including soil condition, historical yield, the seed quality, but also 80,000 different growth stages of crop to provide specific action plan to farmers on what they need to do when, including here's the prediction of what might happen next week, and this is what you should be doing right now, increasing the yield 5%. Now, again, that is sustainable, but it is also providing a direct business outcome, making it easier for the farmers. So we talked about intelligence, but as I said, just having intelligence is sort of like having a brain, but not an ability to act. So let's talk about context. Now, context is sometimes misunderstood as this is all about just data. But as I'll show you, context is a lot more than just your existing data. In fact, there is a tongue-in-cheek statement, and by the way, this is tongue-in-cheek, so take it with that, from a senior scientist at Amazon, that talks about the fact that, like, if you think about this, anything out of an LLM is a hallucination. It is our job, because it's basically predicting the next token and the word. But it is our job to provide it the right context to make sure that that hallucination is relevant to what we are trying to solve for. And this is why there is a growing importance of context engineering. When we think about just optimizing the prompt, you're just providing a one-time input with text. Now, sometimes you give one shot, you give multiple examples, but it is still back and forth. With context in your organization, especially when you're targeting complex workflow, you need agents to understand the role, the hierarchy, the data, the system, the tools. And this is why we are seeing emergence of context engineering roles in this competency in many of the organizations. So to provide this context, let's talk about what are some of the technical capabilities that you need. The first thing is that agents need to understand the relationships in your data. And take example of a relationship looks like, right? Gartner evaluates Magic Quadrant, and Magic Quadrant evaluates technology vendors, right? That's the relationship between different objects and domain inside of your data. If you're a retailer, if you're a media company, if you are a bank, you have many objects, whether it is customer, transaction, their trade, their viewership behavior, where you need to establish this relationship so that agents understand how to navigate your workflows. And this is why knowledge graph becomes important in your data strategy. The second thing that agents need is that they need to understand semantics, which is the adjacency. Because especially around adaptation and understanding the ambiguity, you're not always going to have an exact term that an agent is going to go and search and look for. This is why they need to understand what is closer to what other thing. So in this example, if we were to envision this in a three-dimensional space, cat and dogs both are pets, so they're closer to each other. And Gartner Magic Quadrant and the leading cloud providers are sort of far away from cats and dogs. But if you actually go into second dimension, cats and dogs are not the same family. And so they are farther apart, and the Gartner Magic Quadrant is a lot closer to the leading cloud provider. And this is why the semantic understanding of your data is what AI and agents need. And this is where vector databases come into play. Because vector is the language that agents speak. It provides that you need to provide them relationship, you need to provide them the semantics. But all of this won't matter if you don't have the memory. And when it comes to memory, I want to focus on the bottom right, the four things on the bottom right. Think about priming. Now, priming is sort of like a mindset. It's giving a role to your agent, that you are a financial service agent. That means you're staying in character, you understand what the role you are playing. You then have procedural memory, which provides the agent the how. Right? This is our email system. This is our ERP. And so they have the ability to remember who I am, what I'm allowed to do, and where it is. Then you have semantic. Semantic is sort of like your word knowledge. So the memory needs to understand not just all of the knowledge that is available in the word, but also understand, here is my Q3 sales strategy. And then finally, the episodic memory, so that agents remember what happened last time. So hey, this particular invoice, as I shared in the AP example, had issues 4 times in previous run, so I better remember to address this next time when I'm encountering this problem. Because if you don't provide memory to the agent, it is sort of like having a goldfish, right? It forgets everything, and then you don't get the outcome. And that creates not only poor customer experience, it also destroys some of those behaviors that I talked about earlier, that it needs to get better. It needs to remember. It needs to constantly optimize and improve. So we talked about in the context the relationship and knowledge graph, semantics, the vector databases, 4 different types of memory that the agent needs. But a lot of us know, especially in large enterprises, that a lot of our content is not even in databases. It is actually in documents that look like this, right? And they are designed typically for all of us as humans to understand. We know when we look at this memo to say, it is a large bolded text that looks like a title. There are sections with numbering and the bullets. That means I'm looking at a list. There's a paragraph and this break. We know how to read this, but agents don't. And this is where we need to focus on taking the content that is in a lot of these documents and convert that into .md machine-readable files that are friendlier to agent. Here's a wonderful example from Stripe, and you can read more about it in terms of what they have published, but which is taking our SOPs, our documents, our workflows, our org charts, and making into machine-readable, agent-friendly documentation. Because it's the combination of structured data, memory, as well as content, which is going to give the ability for agents to have this context. And then the final piece of this context is ability to access the tools and actually take action. Now, before MCP, Model Context Protocol, those of you who have dealt with a lot of APIs know this, that every time when you don't have a standard protocol, you're trying to connect to a system, you're building a point-to-point integration. And that is very, very difficult to scale. What MCP has done is it's sort of like a USB-C port for giving agent an ability to access a lot of your tools. And it allows you to have a standard interface across your systems, your tools, your data, so that agents have the context and an ability to access the tool and the information that they need. So the combination of these pieces, the relationship, semantics, memory, better content, and MCP or any other protocol that actually allows it to access to the tool, allows us to move from data just being an asset, which we have heard many, many times, to actually having knowledge as a capability. Because when we are leading in intelligent autonomy, we need an ability for humans and agent to share the knowledge and be able to share back that with each other as well. And we see this, that when you provide the context, the outcomes are amazing. Rufus is Amazon's shopping assistant, and it provides personalized contextual advice. So if you're buying something and say, does it need a AAA battery or AA battery? Or, hey, I bought this other thing in the past. Does it actually work with the product that I already bought? This year alone, over 250 million shoppers have used Rufus throughout the year. And those who use Rufus are 60% more likely to complete a purchase. And that happens because Rufus understands and maintains the context and provides the useful information to the customer. The last piece is the trust, because an intelligent agent that has an ability and the context, but the one that we cannot trust, will never scale in an enterprise. And one way we can be sure about the trust is by setting guardrails. And as part of Amazon Bedrock, we have Amazon Bedrock guardrails, which allow you to set specific guardrails depending on the industry, your company policy. For example, before I joined AWS, I was a CTO for a global media and entertainment company. And that meant that we could not use certain term during prime time in our show. Now imagine having to apply this rule agent by agent throughout the enterprise. Well, that will not scale, right? But Amazon Bedrock Guardrail allows you to mention the denied topics, to say, hey, never provide financial advice. Do not mention competitor. And then that applies to every agentic workflow and every model that you're using from Bedrock, so you can be confident that these guardrails are consistently applied. Think about the sensitive information filter, the PII. You don't want that to be exposed. You can define some of those rules in the guardrails. Contextual grounding checks, which provides information to all of your agents that are at a policy level to say, hey, you know what, our return policy is 90 days. You define it here, and every time there's an interaction, it can, and if there's a conflict, Guardrail will make sure that that is grounded in the policy that you defined there. But one particular area that I want to highlight in the trust is automated reasoning checks. Now, automated reasoning checks is a search for a mathematical proof that a function, a program, an agent did something that it was supposed to do. Now, you're doing this mathematically, and I'll give you an example of how this actually works. So let's say we want to say, how do we know that Pythagorean theorem is correct? Well, one way to do this is to try and draw every single variation of a triangle, and then go and manually measure everything to make sure that the theorem is correct. But that is not practical, right? That is not how we can prove the Pythagorean theorem. The way we actually establish that is by having a mathematical proof that this is correct without having to manually go and draw and measure every single variation of a triangle. That is exactly how automated reasoning works. And as part of Amazon Bedrock Guardrail, automated reasoning checks are available that reduce the hallucination by over 99%. And even before Agentic AI, we've been using automated reasoning for provable security across AWS for a number of years. So S3's public storage and blocking that, or VPC access analyzer, where you can say, hey, does my database have access to internet? Well, how do you actually prove that mathematically so that you have a provable security? We do this through automated reasoning check. And that's one of those tools that allow us to trust the agent and make sure that we are able to effectively scale them in our companies. I'll share an example from Amazon Tax and Compliance. Now, when you're dealing with tax rules and compliance all over the world, you have different policies, different documents, and again, it's very difficult to do this manually. And so our tax and compliance team worked with agents to look at 600 different companies around the world, including the tax policies and the rules, to do the benchmarking. Now, that's an example where the trust is very important, and you have the provable security to establish that trust. Now, after looking at all of this, when you start to move agents and operate multiple agents in production, it is still hard. It requires you to have better runtime so that you can isolate each of the runtime. As I talked about, it needs memory so that it remembers different types of memory that I mentioned earlier. You need to provide an identity to that agent so that you know who's that acting on behalf of and what it is allowed to do. It needs access to different tools. It needs a gateway that it can access information from. And then it needs observability so that you can validate and audit and feel confident that it is doing what you want it to do. Now, all of this requires a set of solid primitives. And if you, as senior leaders, if you go back to like just basic components of primitives or the building blocks, if you had compute and storage, we pretty much can build many different applications. You can create a website, you can create an ERP, you can create a CRM with just compute and storage. We believe that inference is going to become another building block of all of the applications that are going to come out. And this is why with Agent Core in Amazon Bedrock, we provide these building blocks and primitives so that all of the things that I talked about, from identity to memory to providing access to the tool, across any model, across any protocol, not just the models that are on Bedrock, Agent Core allows you to do that so that you can provide agent memory, you can manage the agent identity, you can provide a runtime that you know is secure and is isolated, you can provide the gateway that manages the connection with the other tools. And this is why we are pretty excited about what we can build using these primitives. Now, one of the questions we often get from leaders is, what are some good places to get started? Now, as I talked about earlier, while this is not automation, it is also not full autonomy. They are still early days. And so let's keep in mind that these are still early days, and we make sure that we don't think of agents as a magic wand. In fact, if you have a predictable workflow with fixed steps, very limited tool use, then just basic automation, some GenAI assistant works. Agents are really good when you want dynamic tool selection, when you want to take advantage of that adaptability and learning, where you want to do pattern recognition and matching, where you are looking at things like latency and the cost implication based on the business problem that you're trying to solve. And the three specific areas where we see the biggest value is in software development, customer support and customer care, and the knowledge work, especially when you are handling exception loop type processes. Now, how many of you in the room do not have any technical debt? Oh, that was a trick question. Pretty much all of us have technical debt. And that's a wonderful example where agents can actually help us move fast. Because paying off technical debt locks in a lot of our engineering resources into doing something that must be done, but doesn't always necessarily give better business outcome or features. It is sort of like managing the risk. And here's an example from Thomson Reuters. They had a lot of .NET legacy code that they had to modernize. And they use AWS Transform, which is our agentic AI-based modernization agent. And they were able to reduce and move that modernization 4x faster. That meant that their product and engineering teams can actually solve the business problems rather than just paying off the debt. And so this is a wonderful example where agents are already helping us drive better outcomes. So I would look at your businesses and find areas like that where you can start to apply the agent. Now, none of this matters if we don't prepare our organizations with skill and training. And this is why over the last 25 years, we have invested heavily into the training and certification to build the competency across not only the companies, but around the countries, across the world, so that we have the right talent as leaders to take advantage of this. A lot of this training is available for free. So I encourage not only all of you, but also encourage your teams to take advantage of it. One of my favorite things here is the AWS AI League. What I've found leading product and engineering teams for a long time is that gamification is always a great way to get people highly engaged. It's a low-friction way. You're making it fun. People get to learn something. And that's what AWS AI League does, where you can actually host a competitive, fun league inside of your own company. We also, I believe, announced yesterday that there's going to be a championship league with $50,000 prize where teams can compete into. And finally, you're going to need experts, and we are here to help. There is guidance from AWS experts, many of the folks from our executive in residence team and other experts throughout the company. We have made over $100 million investment in AWS Generative AI Innovation Center, where we bring machine learning and AI experts from all over the company to work alongside you to help you solve a business problem. And then AWS Marketplace, where you can quickly get access to some of the pre-built agents and tools that you can start to deploy today in your organization. It is really a fascinating and fantastic future that is ahead of you, and I'm really excited to see what you all build together. I hope you have a fantastic reInvent and rest of the week. Thank you so much.